enthusiasts and future innovators, welcome to the Battery Forum. It is very good to be a part of this esteemed forum today. Let's jump straight into the critical steps in battery assembly pack. Battery assembly pack, I just want to reconfirm if you are able to hear me and see my screen. Thank you. Thank you. I need to just set up once again to. Need to move my presentation, and I am. So today, as we will be talking about how the battery packs are assembled or battery packs are made from the cells to modules to battery packs, and I will be taking you basically briefly through all these guidelines, giving the very basic introduction of how the battery packs are made and converted from cells to battery pack. So, what is the importance of the lithium-ion battery assembly? So, means these machines are used to increase the production capacity, get the efficiency and speed, consistency, and quality control in the production, cost reduction, and flexibility and scalability. If you will see the, if you will, I hope everybody knows, but still I am trying to take it from the very basic level. So if you will see the first images of a battery cell, how there is a battery cell, and that battery cell we make a module out of the battery cell, and then from module we transform it into various modules are joined together and converted into a battery pack. This is how a battery pack is made, which is later on installed in the various applications made will be EV or the energy storage applications, depending upon the requirements. Thirdly, so now I will take you briefly through the lithium-ion battery assembly process. The assembly process typically involves several steps. First is the cell connections. So the individual cells are cleaned and connected, ensuring a secure electrical connection. This step is critical for optimum performance. Second is the modularization. The connector cells are housed within a module case with electrical connections established throughout wiring harness or bus bars. This step often involves the application of adhesives for structural integrity. Third one is the final assembly. Multiple modules are then interconnected to form a complete battery pack. This stage requires careful alignment and secure connections to ensure reliability. Then integration of the battery management system. A battery BMS is incorporated to monitor and manage the battery health and ensuring the safe operation and longevity of the battery by balancing the charge across the cells. Then that's all about the battery assembly. Then a brief about the cell chemistry. So cell chemistry, there are various cell chemistries available. Different battery chemistries offer varying characteristics such as energy density, thermal stability, and cycle life. Common chemistries include lithium iron phosphate, known for safety and thermal stability. NMC, nickel, manganese, cobalt, offers a balance of energy density and power, widely used in the electrical vehicles. Lithium cobalt oxide, high energy density batteries, and lithium titanium oxide, excellent cycle life and fast charging capabilities. And so when we are going for the cell selections, either you can select it from the cell chemistry, depending on the cell chemistries, or depending upon the performance metrics. That the key performance metrics of different chemistries are nominal voltage, capacity of the cells, internal resistance, C ratings, C ratings. And third selection criteria can be the operating conditions, like consider the environment condition in which the batteries will be operated, temperature range, or the cycle life requirements for the applications. For this next consideration can be the cost consideration. Cost is a critical factor in selection process. High performance cells may offer better specifications. Hello.
Hi, sorry to interrupt. Are you changing the slides? Because I'm still seeing the first slide. I was wondering if you're actually.
No. I am changing the slide. So means I don't know if it's not changing.
Now I see it is on page 3, but before it was only on first page.
Okay. So I will just means. So now you can see the page 2 now, the battery cell module or pack. Yeah. So this is the
Right now,
battery
yes.
cell. Yeah, yeah. So sorry for that. So means I am just uh, moving the slides again. So this is how the battery cell module or pack. What is the difference? So a cell is a single unit of a single unit which is having the which is prepared or which is manufactured. Later on, the cell is various cells are combined to make a module, and various modules are combined to make a pack. So lithium ion battery assembly, as I told you recently, is just now that various cells are connected, individual cells are cleaned and connected, ensuring a secure electrical connection. And modularization, where the connected cells are housed with a module case with electrical connection established through wire harnessing or busbar. This step often involves the application of adhesives for structural integrity. Then there is final assembly. Multiple modules are interconnected to form a complete battery pack. This stage requires careful alignment and secure connections to ensure reliability, integration. And then lastly, we integrate the battery management systems along with the various modules to make it a functional battery pack. So the selection criteria, as I told you, there can be the cell chemistry. Common chemistries are LFP, NMC, LCO, LTO, or maybe the performance criteria depending upon the nominal voltage required, capacity required, internal resistance, or C rating. Or can be the operating conditions, like what are the operating conditions the batteries start to be used, maybe the temperature range, maybe the cycle life requirements, or can be the another consideration can be the cost consideration, because cost is a very critical factor in selection process. High performance cells may offer a better specification but at a higher price. So to balance all these things, you need to select the best chemistry which suits your all these considerations. And last one is the safety and compliance. Safety is the paramount, particularly in applications like electrical vehicles. So thermal stability or the regulatory compliance, there are various regulatory compliances are also there. So you need to select your cells chemistry or the cell types or cell shapes depending upon all these different considerations. So now you can see my screen and these slides.
Yes, yes, yes.
Yes.
Thank you.
So yeah. So now I will tell you about the module assembly. So precision and alignment, accurate alignment of cell is crucial for ensuring the balanced electrical connections and optical performance. Second is the cell configuration. Understand the specific configuration, like how many cells we are putting in the parallel and how many cells we are putting in the series to arrive at the desired voltage or the desired current, and how cells are arranged in series and parallel to achieve the desired voltage and capacity. Thirdly, the thermal management. Effective thermal management is essential to prevent overheating and ensure safety during the operations. Then safety measures. Safety is a paramount in battery assembly to prevent hazards such as short circuits or thermal runways, using insulating components between the cells and ensure proper casing to protect against any mechanical damage and environmental factors. Fifth is the quality control. Implementing rigorous quality control measures ensure that each module meets performance standards and specification. So these are the major criteria. And if you will see the sketch now, so these are the essential requirements for setting up of a battery assembly line. First is the means you can start from the supply chain management, because when you are setting up a battery assembly line, there are in a battery pack there are around 50 to 60 different components, and depending upon the different type of batteries you are manufacturing, so you require different type of material to assemble a battery. Third, secondly, the proper documentation and training which is required so that the step-by-step process is followed for making the battery. Third is the automation and control system, how you will be running your plant, how you will be controlling all these manufacturing systems, and how you will be recording the data in your plant. Fourth is the quality control and testing, how the various testings you will be performing while converting a cell into the pack. It's depend upon the different applications and different tests are required. Third, next is the skilled workforce. This you require for making the battery packs. And then material and components, equipment and machinery, and factory and layout design. These are the essential requirements of setting up of a battery assembly line. So if you will, we will see the very simple diagram I put here. That is, you put the cell, then cells are graded or sorted, and then cells are welded together. Then the BMS is installed. Then battery aging tests are done, and then the battery required battery is there. It looks very simple, but when we go into the manufacturing, there are various small and time-consuming processes which we need to follow uh, during a assembly line. So, if you will see the types of lithium-ion battery assembly lines, it can based on the cell shape, because normally there are three types of cells available: cylindrical cells, second type is the prismatic cells, and third is the pouch cells. Or based on the automation, that how much automation you require or how much production you need to do, for that you require various means, for according to that you need to set up your facility. It can be a manual facility, it can be a semi-automatic facility, or it can be a fully automatic facility. And based on the capacity, that how much production you need to do, production line, lab line, means you are setting up of a production line, or you are setting up of a lab line, or you are just setting up of a small assembly line. So the equipments required for setting up of a assembly line. So there are different shapes of batteries. Therefore, the machines used in the assembly lines are also different according to their cell shapes. These are the most commonly three shapes of the cells are cylindrical, prismatic, and pouch. Therefore, there are three common types of lithium-ion battery assembly lines for three different cell shapes. In general, for pouch and prismatic cells, battery assembly machines are more or less same. For pouch cells, some machines are common, while some of them are different for each of them. So this is a very simple, again, the picture of what are the different processes involved in a cylindrical battery pack assembly line. I had put this simple diagram showing the different machines which are performing the different functions, so that you can understand exactly how the things goes. And in a small setup, these machines are majorly used, or in a prototype setup, or in an initial setup. Most of the companies in India at least use these machines to make the battery packs for small EVs like two-wheelers, or maybe the solar batteries, small solar batteries, solar light batteries, or other power tool batteries, or other various applications. If you will see in the center, it is a picture of a battery pack, that cells and enclosures are shown in a center. So if you will see the process, so when the cells arrive your factory, first thing you need to do is the cell grading. Cell grading means you charge and discharge the cells to determine their voltage and capacity. Based on their voltage and capacity, you will sort the cells. Okay, these cells are of one grade, these cells are of different grade, and you will sort the cells in a different buckets. Once the cells are sorted in different bucket, then you will have the sorting machines, or OCV testing machine, or OCV testing machines. So OCV test, which is number three here. So OCV testing machines sort the machines as per their OCV values, all the sorted cells which you had earlier graded. So now you have these cells in different buckets which are sorted out as per their capacity, voltage, and OCV. Then lot of companies install the paper insulation machine, paper pasting or paper insulation on the cells end to avoid any current leakage during the assembly process. So this is in between is the paper pasting machine. Then once the cells are graded, sorted, and each type of cells are uh, different. The different types of cells are graded, sorted, and kept in the different buckets. Now you take the most most common cells, or most same type of cells from one bucket, and try to do the assembly of the same similar type of cells which are having the same type of capacity, voltage, etc. This will give you the most preferable battery packs. So then once you take that graded and sorted cells, you will do the welding. So I had shown a automatic welding machine. This machines welds the cells from both sides. Then once the cells are welded, Then you install the BMS along with the cells, and before installing the BMS, you normally perform a BMS test. So the BMS, all the BMS are tested that the BMS is functioning properly. And then once the BMS is installed, then we go to the battery comprehensive test machine. This battery comprehensive test machine, you can test that, okay, the battery pack is all the parameters of the battery packs. You can get the all the parameters of battery pack and determine just that the battery pack is performing or the have the required parameters which is required from the battery pack. And once that is tested, then you move the battery pack to the battery pack charging and discharging machines. You charge and discharge the batteries once or twice to activate the complete batteries also, and also to determine the capacities of the batteries, and also to measure the various other parameters of the batteries. This is a very brief process how a cylindrical cell is converted into a battery pack. So the normal machines which are required for cylindrical battery pack assembly. So before going to this, I want to make an announcement that we had provided these equipments to over 200 plus companies in India, and our team had condensed years all of our this experience into a concise book that you can download from the link in the description. The book is free for the first time and it's exclusive for the users who joined here. This book is practical guide and delves deeper into the topics we are discussing today, offering insights that you can apply directly to your work. And it is a completely simple book that you can refer to for almost all things related to battery assembly packs. So I will be sharing the link shortly, and you can just fill up your details, and our team will email you the soft copy of the book. And it is around 100 plus pages of battery pack assembly lines. And besides my presentation, it is majorly focusing on the basics which are starting. It also shows you how the automatic lines works, and how you can do the maintenance of the batteries during their life, repairing of the batteries, and it covers various topics which we had served during the last 7 years of our journey. I hope that you will like the book, and we will look forward to your feedback on the book. Okay. Now again, moving back to the machines to my presentations. So now the machines required for battery pack assembly. Take one second. So if you will see, these are the different battery pack assemblies I had shown you just for your understanding. These comes in various models, various sizes, and various capacities. This is just for your basic understanding. Like one is the cell grading machine. In the cell grading machines, we grade the cells, or means charge or discharge the cells to know the cell's voltage and capacity levels. Second is the sticker pasting machines. Sticker pasting machines, as I told you also in the assembly, that these machines automatically pastes the insulation paper on both sides of the cells, so that the current leakage during the use or during the assembly can be protected. Third is the sorting machines. So this sorting machines also comes in different ranges depending upon the different cell sizes, different cell types, and it uses the precise precision equipment from Hyoki, Japan, for testing the for IR testing. Then fourth machine is the welding machines. The welding machines is used once you gather the cells together, put in a fixture, and then you just slide the fixture into the machine, and machine welds the battery cells along with the nickel plate on both the sides. So these all equipments you can have. There are many equipments available in the market, and lot of equipments are also customized as per the customer needs, for depending upon the battery packs they are making. They are making depending upon the size of the battery packs or size of the cells or different things. So this is just an overview of different type of machines which are available. Then there is the BMS testing machine. From BMS testers, you can test all the functioning of the machines. Also, you can test the CAN communication of the machine, CAN communication of the BMS. This ensures that the BMS which you will be using in your battery pack is good enough. Then once all the battery pack is assembled along with the BMS, this is the battery comprehensive test. In battery comprehensive test, you can check around 14, 15 different parameters of the battery pack immediately after doing the assembly to make sure that the battery pack is assembled properly. So once your battery pack is assembled properly, now it's the time to check the battery capacities and see the DCIR of the battery. So on this aging machines or battery charge and discharging machines or battery cycling machines, these machines are also known by different names. You can charge and discharge the batteries and determine the actual capacity of the usable capacity of the batteries. So this is about all about the cylindrical cell assembly. So same type or a bit different type means processes or the processes remain same, but the equipment used are different for the prismatic battery pack assembly line. So if you will see first machine I had shown is the cell grading machines. So because the prismatic cells are large enough, so the machines are also large enough, having the more current. So suppose the 18650 cells, which are normally below or up to the 3 ampere capacities only. So the battery cell grading machine for the cylindrical cells will comes in the range of around in 3 amperes or 6 amperes or 10 amperes. Now the 15 amperes and 20 amperes machines are also available because the larger cells are available, and the machines of up to 30 amperes are available with us, wherein you can charge or discharge these cells up to 30 amperes. But normally for the smaller cells like 18650, 21700, or 26650 or 32700, normally the 6 ampere machines are used. Same way in the prismatic cells, because the prismatic cells have the capacities much larger current capacities. So these machines are available in 30 ampere, 50 ampere, 60 ampere, 100 ampere, 120 ampere, 200 ampere, 300 ampere in different capacities depending upon how much current you need to charge or discharge your cells, or how much is the capacity of the cells. So now, like normal cells used in a telecom application is a 100 ampere cells. So you normally charge and discharge it by 100 amperes, or maybe by if your process tells you to charge and discharge at 0.5 C rating, you charge and discharge it with the 50 ampere current. So depending upon your process, these machines can be customized and available. So first is the cell grading machines, same like I told you in the cylindrical cells. Then you do the IR sorting of the cells, and once the cells are sorted and graded, and then you take the most common qualified cells, and then you join together the cells by use of bus bar, by laser welding, and in some application even the joining of the cells by even bolting, nut and bolting is also preferred, like in some stationary applications. And then once the cells are welded together, then again the same process, BMS tester is there, you test the BMS and then you install the BMS along with the cells. Then once the BMS is installed, then you will do the battery comprehensive tester to check that the batteries is all the functions of the batteries are performing well. And when the battery pack functions are performing well, you do the aging test. Aging test means same, the cycling test, the cycle test, you charge and discharge the cells. This is the I had shown you very inside view of the battery packs, whereas there are the various different steps which may be involved during making of a battery packs, like you install various type of insulation paper or insulation sheets between the cells, packing of the cells, or you are making the electrical connections, or the putting the battery packs in a box. So means this that all things also you need to perform. This is just how the cells are converted from cells to the battery pack. So if you will see, these are the various machines I had shown you, and full details of these machines are also will be also available in my book. So the cell grading machines comes in various capacities. Then the sorting machines, you can sort these cells Then welding machines. Welding machines also comes in a various capacity depending upon the bus bar you are using. Then BMS testing machines, battery comprehensive machines, charge and discharge machines. These three machines are common, which are used in all types of cells. But yes, their capacities can be different and depending upon your battery pack. But these machines, BMS tester or battery comprehensive tester or charge discharge machines, are most the common machines on which you can test any kind of BMS or any kind of battery, or you can charge discharge any capacity of battery pack. So nowadays means this is the brief about how this assembly works. So nowadays, because this is the basic things, all these plants which you will see for the electrical vehicles, for the energy storage or the large energy storage for commercials or industrial applications or even for the utility scale applications, we have the fully automated battery assembly line wherein you minimum manpower is required, but still yes, at different stages the manpower is required, but very minimum manpower is required, wherein you can do all these process in a assembly line structure, and you can make the battery packs of around means this assembly lines comes in various capacities starting from 8 ppm to around 18 ppm cells for prismatic cells. So these majorly these assembly lines are most common for the prismatic cells and less common for the cylindrical cells. But yes, cylindrical cells, some automatic assembly lines are also available, and and there are various innovations or automation systems or automation processes we are discovering every day, which we are incorporated in our production lines to increase the productivity of the production. So this is a brief about our my presentation, and if you will see now, I will tell you a bit about our company also. So we are a 20 years old company, but in the lithium and battery space, we are working since last 7 years, providing assembly line solutions, and we distribute, customize, and plan and execute the battery pack assembly line projects. And now we are also offering the cell solutions to various companies here in India and try to establish our first cell manufacturing plant in next 6 to 8 months. So if you have any questions, please feel free to ask me.